Hi friend, welcome all to my educational channel Math A to Z. In this lecture, we are going to discuss how to construct a partial differential equation by eliminating arbitrary function. Now we take a relation consisting arbitrary function as, let the relation be phi of uv equal to 0, or the relation may be of the form v equal to f of u. This is named as 1. Here phi and here f be the arbitrary function. U and v both are the function of x, y, z. Now we have to construct a partial differential equation by eliminating arbitrary function, that is by eliminating phi or by eliminating f. We partially differentiate phi with respect to x and we get here del phi by del u into del u by del x into del x by del x plus del u by del y into del y by del x plus del u by del z into del z by del x plus del phi by del v into del v by del x into del x by del x plus del v by del y into del y by del x plus del v by del z into del z by del x. This is equal to 0. Here u is a function of x, y, z. So we differentiate u with respect to x as in chain rule of derivative. Similarly, v is a function of x, y, z. So we differentiate v with respect to x as this chain rule. Now here x, y are independent variable and z is dependent. So del y by del x, this is equal to 0, and del x by del x, this is equal to 1. Similarly, here del x by del x is equal to 1 and del y by del x is equal to 0. So we get from the above relation del phi by del u into del u by del x plus, this is 0, plus del u by del z into p, because del z by del x is p, plus del phi by del v into del v by del x plus del v by del z into, this is also p, is equal to 0. Similarly, if we differentiate this relation with respect to y, we get a relation of the form del phi by del u into del u by del y plus del u by del z into q, because del z by del y, this is q, plus del phi by del v into del v by del y plus del v by del z into q. This is also equal to 0. Now if we eliminate del u, del phi del u and del phi del v from 2 and 3, we get determinant del u del x plus del u del z into p, del v del x plus del v del z into p, del u del y plus del u del z into q, del v del y plus del v del z into q. This is equal to 0. And by expanding this determinant, we get the result as del u by del y into del v by del z minus del u by del z into del v by del y into p plus del u by del z into del v by del x minus del u by del x into del v by del z into q equal to del u by del x into del v by del y minus del u by del y into del v by del x. And this is 4. And this expression can be written as del uv by del yz into p plus this expression del uv by del xz or zx into q, and this is del uv by del xy. This is 5. And we symbolize here this term by capital P into P. This term is equal to capital Q into Q, and this term is equal to capital R. This, and this is 6. And 6 is the first order partial differential equation formed by eliminating the arbitrary function phi of 1. This partial differential equation is known as Lagrange partial differential equation. Here P, Q and R. P, this is a function of x, y, z. Similarly, Q is also a function of x, y, z, and R, this is also a function of x, y, z. And since P, Q, R are the function of x, y, z, and this is linear in P and Q, small p and small q. So this equation is sometimes known as quasi-linear partial differential equation of order 1. If the function P and Q are only the function of x and y, right, and the function R is the function of x, y, z, but only involve the term of z in power of 1, then this equation is known as linear equation of first order. So we form the partial differential equation by eliminating arbitrary function. Now if this relation consists more than one arbitrary function, like phi 1 uv plus phi 2 uv equal to 0, then we also can eliminate phi 1 and phi 2, both arbitrary function, and we can make a partial differential equation. But this partial differential equation must be of order greater than 1. Okay, now we consider one example to explain the method. Here phi is the arbitrary function and we can try to eliminate phi from this relation. We first differentiate with respect to x. We get from this is L, this is 0, this is a into del z by del x, and this is phi dash x square plus y square plus z square into 2x plus 2z into del z by del x, and this gives L plus a into p, right? This is p equal to phi dash into x plus z into p. This implies phi dash equal to L plus np by x plus zp. Similarly, if we differentiate this with respect to y, then we get the relation as phi dash equal to m plus nq, m plus nq by y plus zq. Now equating both phi dash, we get L plus np by x plus zp is equal to m plus nq by y plus zq. By cross multiplication, we get the partial differential equation. We consider another example consisting two arbitrary functions f and g. Now we first differentiate this with respect to x and we get del z by del x. This is equal to f dash x square minus y into 2x plus g dash x square plus y into 2x. Again we differentiate with respect to x this relation. We get del 2z by del x2 is equal to f double dash x square minus y into 2x plus g double dash x square plus y into 2x plus f dash x square minus y into 2 plus g dash x square plus y into 2, and this is named as 1. Now differentiate this given relation with respect to y. We get del z by del y. This is f dash x square minus 1 y into minus 1 plus g dash x square plus y. This is 1. Again differentiate partially with respect to y. Del 2z by del y. This is equal to f double dash x square minus y into minus 1 whole square plus g double dash x square plus y into 1 square. Now here we put this result. This is 1, this is also 1. This result here, and we get del 2z by del x2. This is equal to 2x into del 2z by del y plus 2 into f dash x square minus y plus g dash x square plus y. We put the value of this from this relation as this is equal to 2x into del 2z by del y2 plus 2 by 2x 2 by 2x into del z by del x, right? So we get the partial differential equation as del 2z by del x2 plus equal to 2x into del 2z by del y2 plus 1 by x into del z by del x. This is the required partial differential equation, and obviously this is order 2 because here involved del 2z by del x2, del 2z by del y2. So the order is greater than 1 since it involves, this relation involves greater than one arbitrary function. Okay, so this is the today's class. Thank you for watching.